Okay, today we're going to start by looking at patterns that occur in the powers of I. We learned about I yesterday, knowing that I is the square root of -1, and because of that, I squared is equal to -1. But something interesting happens as we look at larger and larger powers of I. We can actually write them in terms strictly of I or -1 or multiples of those things. So let's look at how this actually works. I to the third can be broken down to I squared times I to the first. And since we know that I squared is equal to -1, that means that I to the third is -1 times I, or just -I. And so anytime that we see an I to the third in a problem, we can replace it with a -I. Next, we move on to I to the fourth. I to the fourth can be broken down as I squared times I squared. And since I squared is equal to -1, that makes this -1 times -1. And -1 times -1 is +1. And so anytime we see an I to the fourth in a problem, we can replace it with a +1. And we can continue to do this for larger and larger powers of I. I to the fifth can easily be broken down as I to the fourth times I. And we just found out that I to the fourth is equal to 1. So this is just 1 times I, or I. I to the sixth can easily be broken down as I to the fourth times I to the second. We know that I to the fourth is 1, and I to the second is -1, and so I to the sixth is equal to 1 times -1, or -1. I to the seventh can easily be broken down as I to the fourth times I to the third. Since I to the fourth is 1, and I to the third is -I, we have 1 times -I, or -I. And lastly, in this little table here, I to the eighth is I to the fourth times I to the fourth. I to the fourth is 1. I to the fourth is again 1, and 1 times 1 is 1. And what we should notice here is there's a pattern as far as what values appear here. We see the same 4 values repeating themselves over and over again. -I, 1, I, and -1. And we can utilize this pattern to help us find the values of even higher powers of I.